Hey guys, today we're going to conclude our statistics chapter with sampling. And sampling is something that you really want to be in class to discuss. And as we're not there to be able to discuss them, um, most of this is already filled in for you. So even though the video is going to be really short, you're going to need to pause and take your notes. So it's going to take a little bit longer than the time actually shows. So as we look at sampling, for an event to be random, there is no predetermined pattern or bias toward any particular outcome. A class of 25 students wants to choose 3 students at random to bring food for a class party. Any set of 3 students would have an equal chance of being chosen. Which of the following strategies will result in a fair decision? Are these scenarios random? And if not, explain. So the students line up alphabetically, and each one in succession flips a fair coin. The first 3 students to flip heads brings the food. Well, this is not going to be a fair sample. It's definitely not going to be random because the students in the front of the line, since they're choosing the first 3, have a better shot since they're going to be flipping the coins first. So this is not going to be a fair random sample. Each student draws a card from a well-shuffled deck of 52 cards. The teacher shuffles a second deck of cards and spreads them out and draws cards one by one until he matches the cards of the 3 students. Okay, this is going to be random because every student has the same chance of being chosen. Here is a random number table. It contains a randomly generated digits from 0 to 9. You can use these numbers to model randomness for sampling purposes. A coach wants to select 3 of her 15 basketball players at random to lead warm-ups before practice each week. The coach assigns each player a number from 1 to 15. How can the coach use the random number table to fairly choose the 3 players? So you can start at the beginning, select 2 digits at a time, ignore the 16 through 99 because you only have 15 students or 15 players, and ignore 0, 0. Start from 1, go to 15. And then just look through there until you've selected 3 players. So 7, 4, and 12 appear to be the ones that would be first chosen. You can use what's called a simulation to assign probabilities to outcomes of a chance process. Suppose you're playing a board game for which you must roll a 6 on a number cube before you're able to move your game piece from start. Describe a simulation you can use to predict the number of times you would expect to have to roll the number cube before you can move from the start. So you can use what's the random number generator. That would be perfectly fine. And you would have a 1 in 6 chance. So at most, it would take about 6 tries to get that done. So there's a problem simulator on your calculator. If you go to applications, which is apps, and 9, you could also use this. It will toss coins, roll dice, pick marbles, spin spinner, draw cards, and random numbers. So if you've never seen this, it's kind of cool. So if I want to roll a dice, I just click roll and I roll a 6. And I can do 10 more rolls. And it shows my data. See, they all almost have an even chance. I can do 50 rolls. Interesting. You have more of a chance of rolling a 1 or a 6. Who would have thought? So that's another thing that you could use. Just like you use the random number generator, you could use the probability simulator in your calculator. So there are sampling methods and types of studies here already defined for you. A convenient sample, select any members of the population who are conveniently and readily available. Those sitting right there with you, if you ask them, would be a convenient sample. A voluntary response sample, select only members of the population who volunteer for the sample. For example, if you mailed out, say, 100 flyers and 10 people responded, those would be 10 in your voluntary response sample. A systematic sample, order the population and then select from it at regular intervals. So if we were sitting in a class with 30 students and I put you in alphabetical order, and then I said, I'm going to choose every 5th student, that would be systematic. In a random sample, all members of the population are equally likely to be chosen. In a class of 30 students, I may put your name in a hat and draw the name. An observational study where members are observed or measured in such a way that they're not affected by the study. A controlled experiment is the sample is divided into 2 groups where there's a treatment group and then the effect of the treatment group. And then there's a survey where every member of the sample set is asked a set of questions. Now we're going to talk about bias. Bias is a systematic error introduced by the sampling method. An example, only surveying a certain age group or excluding certain people with specific opinions. So look at example number 4. What type of sampling method is used in each scenario, and is there any bias? As you can see, if you're looking ahead, they all have bias. So a service surveys every 25th listing in a local directory. That's systematic. The bias, you might not have every number in town listed. B, a reporter interviews people on the street in a large city. That would be a convenient sample. Everybody's in the same place. Bias could be time of day. It could also be the street that you're on. So there could be 2 biases there. And C, a radio station allows people to call in to give their answers to a survey. That is voluntary. People who call in may over or underrepresent some views. You're only talking to people who listen to that particular radio station in that particular area. So there are a couple biases there as well. So to create unbiased survey questions, avoid these things. Avoid combining 2 or more issues, avoid using double negatives, avoid overlapping answer choices, avoid words that cause strong reaction, and avoid leading the subject to an answer. So are the following questions biased? And if so, if they are, explain why. Do you think the food and beverages being served in the cafeteria taste good? Well, first of all, you're talking about 2 issues, food and beverage. Second of all, you're asking them, does it taste good? Not what do you think about it? See the difference? Part B, don't you agree that school days should be shorter? That's definitely biased because you're leading the person answering the question. Don't you think? Like, don't you agree with me? Do you prefer watching exciting movies or reading dull books? There are your words that cause strong reaction, dull and exciting. You're also comparing 2 things there. So this concludes our section on sampling. I think you'll probably find that it's pretty simple and pretty straightforward. A lot of times on the end of course test, they'll ask you what kind of sample that you have, what kind of bias that you have. So it's important that you know and understand those terms. As always, let me know if you have any questions, and I hope you have a great day.